Okay, so seventh graders, we're finishing up here chapter 7. Find the volume of the rectangular prism. So first of all, it's a rectangular prism, so they're all going to be this idea where we have two rectangles connected by a bunch of other rectangles. Like I have a rectangle at the top and the bottom, connected by one at the right and the left, one at the front and the back. And of course, Mr. Swack's great drawing again. You're just going to have to use your imagination. Everything's perfectly straight. Front and the back are congruent. Right and the left are congruent. Top and the bottom are congruent. When we talk about volume, we're talking about how much space is inside. How much can we fit inside? Volume is always measured in cubic units. We've talked about how area is in square units. Volume is always in cubic units and will be written with a little 3. Area was always written with a little 2, the square units. We talk about the carpet. Like if something was 28 square meters, if you had 28 pieces of carpet, all shaped like a square with 1 meter on each side, you could take 28 of those, and that would make 28 square meters. When we have cubic meters, okay, you're imagining a cube, okay? And so if something that say is 28 cubic meters, if you had cubes, 1 meter on each side, and you fit 28 of those, that would be 28 cubic meters. So volume is all about how many cubic units can fit inside. The formula for the area of the volume of a rectangular prism is basically length times width times height. How long it is times how wide it is times how tall it is. Length times width times height. And since it's just a multiplication problem, I have my length, which is 2 4/5, my width, which is 1 3/7, my height, which is 3 1/8. It doesn't matter what order I do the problem in. Okay, I can put these numbers in any order since it's my length times my width times my height, and since it's all multiplication, as symbolized right here, it doesn't matter what order I put it in. So I'm going to start first with 3 1/8 times, and I want to think about where I can cross-check. So sometimes you don't really know how you're going to be able to cross-check, but I'm looking here. This has a 7 at the bottom. So I'm thinking, okay, well, one of these work well with cross-checking with a 7 with what's on top. Well, 8 times 3 is 24, plus 1 is 25. 25 on top and 7 at the bottom isn't going to cross-check well. But 5 times 2 is 10, plus 4 is 14. A 14 will cross-check well with a 7. So I'm going to start with these two. Well, 5 times 2 is 10, plus 4 is 14. So I'm going to write 14 over 5. And that's going to be multiplied by my 1 3/7. 7 times 1 is 7, plus 3 is 10. 10 over 7. And that really works out really well because I can cross-check a 7 and a 14 by dividing by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. I can cross-check a 10 and a 5 by dividing by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. And 2 times 2 is 4. 1 times 1 is 1. 4 over 1 equals 4. And so that's pretty straightforward. Now I've got to take 4 times 3 1/8. Well, 8 times 3 is 24, plus 1 is 25. So that's going to be 25 over 8. I'm multiplying that by 4. I'm going to put that as a fraction, 4 over 1. Nothing besides 1 will go into both 1 and 25. But I can divide the 8 and the 4 both by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. 25 times 1 is 25. 2 times 1 is 2. It's an improper fraction. It's in simplest form because nothing besides 1 can go into both 25 and 2. Plus, there was no more cross-checking that could take place. 2 can go into 25 12 times. There's 1 left over. My denominator is 2. My unit is meters, so it's 12.5 cubic meters, or meters cubed. And that is my final answer. All right, well, let's look at another one. Here's an interesting one because the length is 4/5 meters, the width is 4/5 meters, the height is 4/5 meters. So all those dimensions, the length, the width, and the height, are all the same. That means essentially, even though it may not look like it in the picture, what I have here is a perfect cube. So it's essentially going to be 4/5 times 4/5 times 4/5. Well, so let's just go ahead and start. Let's go 4/5 times 4/5. And well, 4 times 4 is 16. 5 times 5 is 25. I can't cross-check a 4 and a 5 either direction because nothing besides 1 can go into both of them. So I can be confident that 16 over 25 is in simplest form. But it's 4/5 times 4/5 times 4/5. So 4/5 times 4/5 got me 16 over 25. But now I need to take my 16 over 25 and multiply that by 4/5. I can't cross-check a 4 and a 25. Nothing can go into both of those except 1. I cannot cross-check a 5 or a 6 and a 16. Nothing besides 1 can go into both 5 and 16. So I'm just going to have to go ahead and multiply. Might need to do a little bit of scratch work. 16 times 4. Well, 4 times 6 is 24. Put the 4 down, carry the 2. 4 times 1 is 4, plus 2 is 6. That gives me 64. 25 times 5. 5 times 5 is 25. Put the 5 down, carry the 2. 5 times 2 is 10, plus 2 is 12. I get 125. And since I couldn't cross-check, I can say in confidence that 64 over 125 is in simplest form, which it is. Nothing besides 1 can go into both 64 and 125. Once again, my unit is meters, so my final answer is 64 over 125, because that's what I got there, but it's going to be meters cubed, or cubic meters, and that is my final answer. Part of your assignment today is going to be just that. You're going to be given rectangular prisms with a length, a width, and the height. It's your job to do the multiplication. Use that formula, length times width times height, to find the volume, and it's always in cubic units. All right, there's one other aspect to this, and so we've got one more example, and it's still going to be that same formula. Volume equals the length times the width times the height. The directions tell you to find the missing dimension of the rectangular prism, to find the missing dimension, which means they're already going to give you the volume, okay? And they're going to give you 2 of these. They're either going to give you the length and the width, the length and the height, or the width and the height. And it doesn't matter what 2 they give you, you do it the same way. They're going to give you 2 of these, like we said. They're like this one, they give you the length and the width. Sometimes they might give you the width and the height. Sometimes they might give you the length and the height. It doesn't matter. Whatever 2 they give you, you're going to multiply those together. Okay, just like you're following this, length times width times height. So length times width is going to be 64. So I multiply those together and I get 64. Now, so I know that the length times the width was 64. What I don't know is the height. Okay, so I can basically say that 64 times the height, which is going to be 64h, equals the volume, which is 460 and 8/10. And you can just set up a little equation. I don't even necessarily need to see this, okay? But you can kind of envision that that's kind of what's happening. And it doesn't matter which dimension is missing. If you were multiplying the length and the height, it'd be whatever that was times W would equal the volume. If you didn't know the length and you were multiplying the width and the height, it'd be whatever that equaled times L would equal the volume. Okay? So basically now it's basic equations, okay, which is why we do equations before we do this. I know in this situation to isolate H, basically I'm going to divide both sides by 64. So simply speaking, I'm just doing 8 times 8, which is 64. I'm multiplying whatever two numbers they give me, and then I'm dividing my volume by that. So it's 8 times 8, which is 64, and since I'm dividing 64 by both sides, all I'm doing is 64 going into 460 and 8/10. I'm going to put my decimal straight up. So you can think of it algebraically. You can also think of it simply as it's 8 times 8, which is 64. Whatever the product is of the two numbers that I multiply here, I'm dividing my volume by that number. Well, 64 is going to round to 60. Now I'm just remembering basic long division. 6 cannot go into 4, but 6 can go into 46. And I'm going to think that the number of times that 6 can go into 46 is the same number of times that 64 can go into 460. Well, I know that 6 times 7 is 42, and that 6 times 8 is 48. So 8 would be too many. So I'm going to try 64 times 7 and see what I get. 7 times 4 is 28. Put the 8 down, carry the 2. 7 times 6 is 42, plus the 2 is 44. Well, I like that. That seems to make sense. 448 is less than 460, but it's not 64 less, okay? So I'm going to put 7. I'm going to put 448. That seems pretty close. I'm going to borrow from the 6, make that a 5, make the 0 a 10. 10 minus 8 is 2. 5 minus 4 is 1. I know that 4 minus 4 is nothing. I'm going to go ahead and bring down my 8. All right. And I know that 6 can go into 12 twice. So I'm going to come over here and I'm going to try 64 times 2. Well, 2 times 4 is 8. 2 times 6 is 12. I get 128. Well, that works out perfectly. So I can put my 2 there. 64 times 2 is 128. 128 minus 128 is nothing. I find that the height is 7 2/10 meters. All right? That's what you're doing. Like I said, it doesn't matter which two dimensions they give you. You multiply them together, then you divide your volume by whatever you get there as your product. All right, that's volume of rectangular prisms. Talk to you later. Bye.